Excellent. So next speaker is Phillip Oertel, and he's going to talk about software craftsmanship.
Yeah, welcome to my talk on software craftsmanship. Let me say one word about myself. I'm from Germany, currently living in Hamburg, and I've been developing for the web, mostly the web, for about 10 years now, and spent last 2.5 years working for a European social network called Zing. First as an employee and currently freelance. So I'm going to talk about software craftsmanship, subtitle for better software. Let me first give you an overview what I intend to talk about. Where does this term come from? Is it new? Has it been around for a while? Why do we need this? How does it help us in our profession? And what does software craftsmanship demand from us? So first, how did this term arise? Why do people call themselves craftsmen, software craftsmen? You see, in the past, when I was preparing this talk, I was reading a lot on the internet, and I realized that software developers compare them to all sorts of different professions. We compared ourselves to artists. Paul Graham has a famous essay online, Hackers and Painters, and he's both. And he says that no two things that he knows are so alike as hacking and painting something. And when I talked to the artist that's painted this, I realized that we both start out with a completely blank slate and just an idea in our head. And then we use technique that we have learned through practice to get to this result. But the result is more than just technique. It is something that speaks for its own. Software developers have also been compared to musicians. And I sure know that when I'm hacking away, I can completely get lost. And at 2 o'clock in the morning, I realize, ooh, I haven't eaten, I need pizza. So you completely get immersed and get into the flow, just like a musician. Software developers compare themselves to writers. There's one analogy that when you're writing code, ideally the functions and objects should tell the story about how your application works. Should be very expressive. This is why we're happy to have Ruby, because it's such an expressive language. It really makes us good software writers. And of course, we are architects. Architects in that our products are a collection of a myriad of small details that all together have to be coordinated and structured in some way. And these many people have to be coordinated. And of course, we are engineers. We use logic. We plan. We measure performance. We need to be very exact in details. If we forget a comma, the machine will say, no, go douche yourself. I won't run your program. So I was confused. Another metaphor, another idea, another way of comparing ourselves. It didn't really make sense. On the other hand, we were not alike, not exactly like one of these. None of the comparisons fit perfectly. We all have some parts, but not everything. So I say, first of all, we are software developers, professional software developers. That's good enough. Of course, if I had said I'm going to talk about software development, you wouldn't have come. You wouldn't have turned up. That's boring. We know that. But I think we're in a bit of an identity crisis. We are still searching. What exactly is it that we're doing? It has aspects of different things. It's creative, it's technical, it's logical. And still, for me, software craftsmanship, this term that has been coined, is just being a professional software developer. Here's a nice image of a craftsman. By calling yourself a craftsman, you say you care. And that's a big comparison, that you bring in values of traditional craftsmen, the qualities, to the software world. Let me give you a quick overview of what has been written and done on this topic. There's Jason Gorman. He's blogging on this topic of software craftsmanship. He also organized a conference in London earlier this year, Software Craftsmanship. And his definition of a craftsman is someone who applies skill and care in the creation of a high-quality product, in the creation. One thing that all the previous professions that I just showed you share is that they are makers. They create stuff. So that's a big similarity. Earlier, 2002, Pete McBreen wrote a whole book comparing, called Software Craftsmanship, and seeing how we can apply these values of craftsmen to our profession, how that will help us understand ourselves better. Recently, Robert Martin, or Uncle Bob, has written a book called Clean Code, a handbook of Agile software craftsmanship, where he goes into very much detail which are the specific technical practice that all of us should dominate. And also earlier this year, the Software Craftsmanship Manifesto, which builds on the Agile Manifesto, was discussed and put online. So why do we need that? Why do we need software craftsmanship? Why do we need another word? I think it is because there are many problems in today's software development, and we're just understanding this problem and just these problems and how to best deal with them. And just by saying we're software developers, it doesn't cut it. We need a new new phrase to build this around. So let's look at some of the stuff that you all know. The epic fails that we currently face in software development. We don't deliver on schedule. Everything takes longer than we expected. We don't hit the right requirements right. It's really hard to build what the customer needs. And code quality. I think over time, almost any commercial code base becomes a mess. At least that's what I've seen in 10 years. And I'm trying to understand. And software craftsmanship says, this is our fault. We are the ones that write these applications. We are the ones that have to change these things from happening, or no one will, because we are the ones that understand best, and we are right at the center. So we shouldn't be saying, yeah, you know, it's the schedule or the bad manager. I'm here, I can't do anything. We have to take responsibility. And this is where craftsmanship comes in. You take the attitude of a craftsman and say, okay, it is my job not only to deliver something that I've been told, but to work with the whole process and care about things becoming better. So there are two important things to be learned. Two general things. First, the current practice, how we are working, and the second, and I think even more important, how people that come new into software development practice that software craftsmanship addresses. So what about values? I'm only giving you an overview here. It's much deeper. You can dive into this much deeper. Just some relevant things. Some values that you pick up as a developer. Responsibility is a key point. Don't reduce yourself to just being a hacker. Help improving the profession, make it better understood for us and for people that are non-technical. I talked to a marketing colleague when preparing this talk, and I asked him, what do you think I do? He had no idea. No, our output is invisible. And it's just a program and not even it's an application, but even the application is not our product. Our product is what we write, the source code. You can have a working application out there and it can be crap. It can run against the wall in 6 months, although from the surface it looks nice. And something really interesting in Josh's talk, when he logged into the EC2 instance, did you realize something in the commands at the beginning? It said somewhere, this Ubuntu image built by Eric Hammond. The guy signed his work. He's the one that built this application, this instance together. And if it goes wrong, you know who to blame. So craftsmen sign their work. They take responsibility for what they're doing. And I had this weird idea. Think about this. What about if we change our editors to always show the blame on the lines while you were working it? Who wrote this line of code? You're working in a team of 10 developers. Would that change the way you work? Would that change the way you code? So you know, everybody will always know what I've written. It's curious to think about that. One other thing, practice and learning. How do you get this flexible, not overnight? You get better and better day by day in small increments. And again, I know I'm here, I'm at a conference where people that want to learn, I'm speaking, so I'm basically carrying owls to Athens, but bear with me. When we well practiced, things are easier. Our resistance to change and improve is lower. Professional musicians practice, but we always produce. Practice means writing something that's never going to be used, that's just for exploring. How often actually do we do that? Discipline. I think that's a thing we need as professional. It's just professional. We can get programs to work fairly quickly, and we can show the results around, but we know that it's not better, that it's not right yet. That doesn't, it's not good code quality, it's not maintainable, things like that. But we stop early. And I think we need to have more discipline to really write things in a more clean way. This also means understanding that saying, yeah, we're going to fix this later, actually means never. I went through the to-do comments in the application I'm working on, and we had stuff from 2007 in there, and the developers were gone that were actually doing that had written the comments. So get rid of this illusion that you're going to do it someday. You're not going to do it someday. And I already mentioned this, just because our users can't see the code, it doesn't mean it can look crappy. Let me talk about some practices. Again, you know what you're doing. You'll have seen many of these. Use current practices. We do iterative development, whether it's XP or Scrum or your own brew. We do this in the small and in the large. We do this when we write one function. You do it iteratively. You don't try to get it perfect at the very beginning. You make it work, then you make it right, and then you make it fast. That's, I think, something that Kent Beck once said. And the large, of course, you use iterations. You don't deliver the whole system in a waterfall, but in small steps. This is an interesting point about software craftsmanship, especially in the book that was written in 2002. Pete McGreen writes a lot about software engineering and how it's been really evil to software development, because people thought that we can break everything up into strict phases and plan everything in detail. And that may work if you're building space shuttles and if lives depend on your work, but it's really slow and it's incredibly expensive and tedious. So well, we've learned that iterative agile approaches work better in the typical things that we today build. We're not building rockets, most of us. Automated tests, no-brainer. They make software flexible. They take your fear of changing things. Keep it simple. Do the simplest thing that possibly can work and design for the current requirements. You can always come back later and enhance stuff. Work closely with the customer for several reasons. Of course, they're the ones that have the domain knowledge. They know best what their job is about. And directly facing people at a desk also builds trust. And a big advantage is that you have no handovers, you have no intermediate. Every handover adds overhead, adds misunderstandings. So it's best to work directly with your customer. Continue small improvements, no big redesigns in the sky. And one thing that was mentioned is, what if every time you open a source file, every time you do a change, you leave the code a bit better. You make a small improvement there. Just improve a comment or get rid of one variable, or things like that. Over time, quality would increase, but it doesn't increase. Usually in our daily work, I think quality decreases. This is a nice one. Can you read that below? It says, reading the code from the previous day. I think we often fall into the trap of writing for computers and not for humans. Code is read much more often than, or understood, read much more often by a human than than written. So it's important to make it as comprehensible as possible, which you at a Ruby conference will know, because Ruby is a very expressive language. One idea that I found interesting is think of code in flux. Think of code that's as not something always changing, non-permanent, that's not set in stone. This will give you a different mindset. It will say, it will prevent you from refining things in perfection. You will just do enough to get it work, to make it right. And later on, it would also tell you to, since when you know, I will come back and change this, you will write stuff that's easy to comprehend later on. Easy to change code. And test-driven development does exactly that. It only, when you do practice test-driven development, you only write the code that's absolutely needed to implement your feature. Refactoring is a skill I think that we should be better at, especially big refactorings. I recently worked with a colleague on about 600 lines of code of Ruby. It was an inheritance with some service, an abstract class and 2 base classes. And that was all kinds of responsibility in these classes mixed around. And by following a step-by-step process, we got from this design to a good design in a controlled way without tearing everything apart. But this is something that you don't just do. You can do small refactorings in your brain, but you can't do big refactorings without a structured approach. And then we ended up with 5 smaller classes that all had a single responsibility. They were easy to understand, and the good thing was we got knowledge that had developed meanwhile. We got knowledge back into our code. We had understood the code better, what these objects were actually doing, and gave it names. Okay, I'm going to skip over these really quickly. What are the hard basic skills? Even lower. These are practically direct and taken off from the clean code book. How to write comments, how to write functions, unit tests, meaningful names, error handling, concurrency, boundaries. Do we manage these like a surgeon, like a surgeon doing a routine operation? Would you say that of yourself? I can't, to be honest. But I think this should be a common body of knowledge for every software developer. Functions, small, they do one thing. They're written at one level of abstraction, which means you don't open a database call and next line call a high-level function to send mail. You have one level of abstraction all the time. You use descriptive names. You know how many function arguments to use. One to use a method has 0 functions, 0 arguments, 1, 2, what's the smell. Functions have no side effects. You prefer exceptions to handle errors, and you don't repeat yourself. So that's for the skills part. Something interesting about software craftsmanship is how they want us to learn. How do you learn the classic crafts? Or how do you become a medical doctor? I know it's not a classic craft, but still. To become a medical doctor, you have to study, and then you're taken slowly into the profession in a course for 1 to 2 years. How do you become a software developer? Basically, you turn on the computer and you hack away, right? And Software Craftsmanship says you have to go through these stages of apprentice, journeyman, and master. And it's part of our job to help newcomers come in and tutor them and mentor them on their way. They say that software development is mostly learned by situated learning, which is basically lots of programming under guidance or with more experienced people. You cannot teach that in a classroom. You cannot teach that software development at a university. So it's our responsibility to gather and pass on what we know already, because the knowledge is in our heads. And this interesting point is that they ask us to stay on projects for long term. Why? Because only if you've been developing an application over a long time, you will understand if your earlier decisions were actually right. If you start working on a new project every half year, you will never learn if that design worked out or not. And I think a big problem at the moment is that we lose lots of knowledge because it's not common for people to stay programming for their whole lives. At some point, they go into management or they go into other positions, but they stop coding. They become the architects. But this knowledge that they've built up gets lost. And again, newcomers on their own make the same mistakes while learning. And this reinforces the problems that I mentioned earlier. So we need a technical career path. And I think our own image is also important. Values and skills are not enough. I think what we think of as our profession is important. We should stop seeing ourselves as, coders. Or technicians. Here in Spain, they call software developers técnicos. I was scared when I heard that. I don't feel like a technician. We should think of ourselves as partners in developing software and experts of that, but not the receiving end or the technical part only. There's so much more to our profession. So I'll close with a thing that Paul Graham wrote, which I liked a lot. He says, every once in a while a new medium appears, and people are so excited about it that they explore most of its possibilities in the first couple of generations. I think that we are right now working with such a medium, software. We're one of these first generations. So let's keep trying, doing our best, and I think it's going to work out. Thank you.
Okay, any questions? Stand up, please.
It's not really a question, but it's something I struggle with. Your comment about the to-dos in the code.
Yeah.
I have the same reaction. I want to fix them, but we shouldn't. There's a judgment in there about return on investment and that kind of thing. And related somehow is do we give customers or business what they want and ask for, or what we know is good for them?
Yeah.
And so negotiating this whole value judgment is really, really hard, I think.
I agree completely. That's a very important thing that you mentioned. What's best for the customer? Is it best to fulfill what they short term want and be quick and fast, or should we understand that this application will live for years and the quick wins in the short run will bite us very, very soon? I think small site and you're absolutely sure that it's not going to live for long, you should work what your customer asks you to implement it quickly. But fact is that most more complex software systems live for much longer. But they've been written for the short term in a hurry. So I think we need to be more resistant and explain better what the consequences are, because it's not understood what the consequences are. People don't know what code, what good code or bad code is. And yeah, regarding to do, it's about the same. It's about the same answer. I think we should fix them.
Okay. One of your slides mentioned losing masters, and I'm just wondering, do you think this can also be seen as a positive thing in a way? I mean, software development is evolving quite rapidly, and knowledge gets outdated pretty quickly.
Yeah.
So in a way, this is a process of natural selection, and new people coming into they bring in new ideas, they bring in new solutions, and maybe this process is actually quite positive and it works well for software.
Yeah.
Could you elaborate on that?
That's a good question too. Of course, if someone wants to write COBOL for his whole life, then maybe it's not a bad thing if he sometime stops writing code. But the software craftsmanship model says that you're constantly learning, so even the old-timers would be old-timers, would be keeping up with stuff, with recent development, and they would be challenged by people coming in, by apprenticeships coming in, bringing new ideas. So this whole small ecosystem keeps itself alive. It's not that you have these guys and they learn for 20 years and then they stop. It's a constant process, so I don't think that sending away people that are up to date is a good idea.
But maybe, maybe if they're actually willing to step down, move on to something else, maybe they weren't really masters. I mean, they did have their own knowledge, they did have their own experience, but if they believe that they are better at something else and they should be doing something else, maybe that's the way to go.
Of course, if you don't enjoy the job, then you should move out. But I think often the reason also is that there's just no way to proceed in a company or an environment. but to exit the technical path. I mean, you can get as high as CTO, but as a CTO, you're not developing software. You're not handing on your knowledge any further.
All right. Cheers.
Sure. Anyone else?
Okay, so thank you very much.